Okay. A type of problem that we're going to see frequently in this class. We're going to do enough examples where you're going to be like, oh, we do these all the time, are called mixing problems. Here, we're going to assume that we start out with some amount of liquid in some tank. We're going to be pumping fluid into the tank and mixing it all up. And then some will be removed. So take a moment, read over the problem, and then we'll start talking about what our variables should be and what principle we're going to use to set this up. All right, so, okay. So there's a lot going on here. Let's draw a little bit on the picture to get a sense of what's happening. So we're starting off with 100 liters of water. Okay, we are pumping sugar water in. It has a concentration of 2 kilograms sugar per liter, and we're allowing 3 liters in per minute. And what is coming out? We have a 1/2 liter per minute leaking out. Okay. And this part is well mixed. Okay. So we were given the variable that we're supposed to use. S is going to be the amount of sugar that's in the tank. So S is going to be kilograms of sugar in the tank. Our other variable is time. All right. Okay, so the physical property that we're going to use here is that the total rate of change. So our interest is in describing the rate of change of the amount of sugar overall. Okay. So this is the total rate of change of amount of sugar. This rate is going to be equal to the rate of sugar in kilograms per unit time, so per minute. Minus the rate of sugar out. Okay. We're breaking it down this way because it's easier to sort out what is happening if we look at it little piece by piece. Okay. So let's begin by thinking about how much sugar is coming into the system. Okay, so rate of sugar in. So take a look over the problem, and we're just going to be focusing on this input part. Can you set things up so that we have so that we know how many kilograms per minute are coming in? Okay, so what we can take is the concentration that we know, which is 2 kilograms per liter. And we also know how many liters are coming in per minute. So this is the concentration times the amount of liquid in. the rate that liquid is entering. Okay, which was 3 liters per minute. Multiplying this out, we see that we have the correct units. We end up with 6 kilograms per minute of sugar being added to the system. Okay, so I'm just going to write this on the side. ds dt is equal to 6 kilograms per minute. And then now we're going to find the rate that the sugar is exiting. Okay, this is again going to have units of kilograms per minute. And if we think about what we did in the last, when we were calculating the rate in, we had the concentration of the solution that was moving times the rate of the volume that was entering. In this case, we'll look at the rate of the volume that is exiting. Okay. So first up, here's our rate that the volume is exiting. We had 1/2 liters per minute. And next, let's take a look at our concentration. So we said the concentration is going to be whatever the concentration of the solution is when it's all mixed up. So concentration is going to have units of kilograms per liter. And we have a convenient variable that tells us the number of kilograms of sugar. That is just S. Okay, so the amount of sugar that we have in the system is just S. And then we're going to look at the volume. Okay, so we started off with 100 liters. But every minute we have 3 liters entering and just 1/2 liter exiting. Okay, so each minute we add an extra 2.5 liters to the system. And so what we're going to see is that our volume is always going up. And so our concentration is going to be how much sugar we have in the system, S, divided by how much volume we have in the system. We started with 100, and then we are adding in 2.5 liters times the amount of time that has passed. Okay, and checking our units, we had kilograms per liter times liters per minute. This is going to give us kilograms per minute. So it has the correct format. So this is going to be 1/2 times S over 100 plus 2.5 T. All right. Woo. Okay, so this is our differential equation. We are almost done. We wanted to set up an initial value problem that described the amount of sugar in the tank. Okay, so we have the differential equation part. The only piece that we're missing is how much sugar we want to start with. So take a look at the problem and think about what should that initial amount of sugar be. That's right, we're going to look at 10 kilograms of sugar, which is what we started with. So S at 0 is going to be equal to 10. Okay, and we've done it. This is our first mixing problem. All done. Good job.